In this video, we're going to go over how to find the area of a regular polygon. In order to be successful, we need to first go over some vocabulary that we're going to come across. So the first thing we have is going to be in a regular polygon. So that just means all my sides and angles are congruent. A segment that is going to be drawn from your center of the polygon so that it is perpendicular to the side is going to be called an apothem. So in the figure to the left, we have that PS is an apothem. A segment that is going to be drawn from your center of your polygon to a vertex is called a radius. So in the figure to the left, PA would be a radius. So let's come over here and let's label that. So we had first off that P to S is going to be my apothem. And you'll see that a lot of times I'm going to label that with a lowercase a. Then they also told us that from P to A to a vertex, this line here would be our radius. I'm going to put an R there because we use a lowercase r to show for the radius. So looking back at it, we have the area of a regular polygon can be found by dividing that polygon into congruent isosceles triangles. So for example, we had that pentagon, and you can divide it up into 5 triangles by drawing all 5 radii. If a regular polygon has n sides, so your number of sides, then it can be divided up into n triangles. The same number of sides will tell us how many triangles we'll have. So I'm going to come over here and I'm going to draw all of my radii real quick. So doing my best to do that. That would be a radii. We would have one here, down here, and over here. So they're not perfect, but you get the gist of it. So this would be, we've got 1, 2, 3, 4, 5 of those isosceles triangles they were talking about. So keep in mind, and I'm going to read through the rest of this without kind of going back and forth, to find the area of a triangle. So for example here, I can look at this triangle here and find its area by taking 1/2 of my base times my height, since it is a triangle. Okay, but we just talked about the fact that in the regular polygon, we refer to that height in this triangle as our apothem. So I'm going to have 1/2 my lowercase a for apothem. And then the base of this right here is just going to be our side length. So I'm going to multiply by S, which will stand for my side. So that's going to be the area of this one triangle that we have here. But since I have 5 triangles, I'm going to multiply this by my n, my number of sides, or in this case 5, to find the area of the entire thing. So we would have that 1/2 our n, number of sides, times our apothem, times my s. That would be the area of this entire figure. But we are going to condense this even more. Okay, so the n times s is just going to give me p for perimeter. So I can rewrite this to be 1/2 the perimeter of this figure times my apothem, and that's how we are going to find the area of a regular polygon. So if you look over here, I actually have this formula shown. right here. All right, so now let's look at some practice problems to figure out what we can do to solve them. All right, so we're starting off with number 1. In number 1 here, we have find the area of a regular pentagon. So keep in mind, pentagon means it has 5 sides with a perimeter. So my P is going to be equal to 54.49 meters. And an apothem, it's going to be equal to 7.5 meters. So to find the area of this regular pentagon, we are going to take that 1/2 of my perimeter, 54.49, times my apothem, we got that 7.5. Okay, so I'm going to plug this into my calculator to speed things up a little bit, but we've got that 1/2 of the 54.49 times 7.5 is just going to give us 204.3375 meters squared, since this is area. And that's your answer for number 1. Now let's look at number 2. Okay, and number 2 here, they say find the area of a regular hexagon, so we have 6 sides, with our apothem being equal to 5√3 centimeters. And each side, so my S, is going to be equal to 10 centimeters. In order to find the area of this regular hexagon, we need to find the perimeter. So I'm going to start off by taking the side length of 10 and multiplying by my number of sides, which is the 6. So 10 times 6 is going to just give me 60 centimeters as my perimeter. Now I have everything I need to find the area. So for my area, I'm going to take that 1/2 of my perimeter, 60, times my apothem, that 5√3. Well, half of 60 is going to give me 30, and 30 times 5 is going to give me 150√3 centimeters squared. Make sure you are squaring your units. Okay, moving into number 3. We have find the apothem, the area, and the perimeter of the equilateral triangle to the right. Okay, so we are going to, I'm going to split this up here to form these lovely right triangles that we are going to deal with. And so we currently know my apothem is that 7 feet. So that's one of my answers, so I'm going to write that out. I still need to figure out what is my perimeter so that I can find my area. In order to find perimeter, I need to know what is the side length of this figure. Okay, in order to do that, I need to know some angles in this figure. Now, this one is a very easy one that we can do. Okay, we all know that this is an equilateral triangle and that each angle is equal to 60 degrees. Okay, but over here when I drew this radius, I bisected that 60 degrees to get 30 degrees. And so you'll see here we have that 30, 60, 90 triangle happening. So I'm going to label my ratio, which we know opposite of my S should be, opposite of my 30 should be S. My hypotenuse is going to be 2S. And then opposite of that 60 should be that S√3. Okay, well, when you have an apothem being drawn, it's going to bisect the side. And so therefore this side length here in my equilateral triangle would just be 2S√3. Well, I'm going to replace that s with the 7 that we said it's equal to. So I have 2 times 7 root 3, which is just going to give me 14 root 3. So in order to find the perimeter, I'm going to take my side length, and I'm going to multiply it by the number of sides, which we know is 3. So 3 times 14 root 3 is going to give me 42 root 3, and then we'll have that feet. Okay, now that I have my apothem and my perimeter, I can plug in to find the area, which is going to be 1/2 my perimeter, 42 root 3, times my apothem of 7. Okay, half of that 42 is going to give me 21 root 3. And when I multiply the 21 by 7, I should get 147 root 3 feet squared. Okay, and that's it for number 3. Now let's look at number 4. Find the apothem, perimeter, and the area of a regular hexagon that's going to have a side of 8 inches. Okay, so I'm going to start off here by just labeling my picture with that 8 inches as my side. Okay, so they did have a note here, and that note is telling us that a hexagon is going to be made up of 6 congruent equilateral triangles. So because of what they're asking for, I'm going to work it through finding my apothem, my perimeter, and then my area. Then I'm going to show you another way you could do this if you are just looking for the area. So let's look and see how we could solve this. So starting off, we need to figure out some angle measures. Up above in number 3, you knew a lot of the angles already, okay? And while yes, I am saying this is an equilateral triangle, let's assume we did not know that, okay? So here I can see that I have 1, 2, 3, 4, 5, 6 triangles where these angles are forming a 360-degree angle, okay? And so in order to find the measure of just one of these angles, I'm going to take that 360. I'm going to divide by n, which is also going to be your number of triangles, to get 60 degrees. So each one of these angles has a 60-degree angle up top. But keep in mind here that when I draw my apothem, I'm going to bisect it. So instead of dealing with 60, I'm going to be dealing with 30 degrees here, which will then leave me with 60 down here and a 90-degree angle here. So give me one sec. I'm going to redraw this to be a little bit bigger so you can see easier. Like I said, this angle is going to be 30, and then 90 and 60. Okay, so that 8 inches that was given, okay, that is going to be the full side length, which keep in mind, once again, when I drew that altitude, that apothem, I am going to bisect it, okay? And so I actually have here 4 inches for this length. So using my ratios, I have my S root 3, and then 2S. So since my S is 4, I can use substitution to figure out that my apothem is going to be 4 root 3. So my apothem is equal to 4 root 3, and our units are inches. Then I can move into my perimeter. Okay, keep in mind perimeter can be found by taking your side length and multiplying by the number of sides. So 8 times 6 is going to give me 48 inches for my perimeter. And then lastly, to figure out my area, I'm going to just plug in, we've got our 1/2, our perimeter, 48, times my apothem, 4√3. Okay, so I'm going to take half of that 4, which gives me 2. 2 times that 48 is going to give me 96. So I'll have 96√3 inches squared for my area. And that's my answer for number 4. Now, like I said, keep in mind this here is because of the fact that they were wanting all of the in-between steps, my apothem, my perimeter, and my area. I'm going to, off to the side over here, show you using that note that they kind of gave you. Another way to find this area for the hexagon if you knew your side length. All right, so keep in mind, like they said, that we are going to have 6 equilateral triangles that are making up my hexagon. And so if you recall, we've had a lesson over the formula for area of an equilateral triangle is going to be 1/4 your S, your side squared, times √3. So plugging into that, I would have 1/4 of my 8 squared √3, which is just going to give me 64 √3 over 4, and that's going to simplify to give me that one equilateral triangle will have an area of 16 √3 inches. Sorry, squared, inches squared. Now that's for one equilateral triangle. Since there are 6, I would just take that 16 √3 times 6 to get 96 √3 inches squared for my final answer of the area of this hexagon. So there is a shortcut formula, another one that you would have to memorize if you want to. Okay, so because we know one equilateral triangle is going to have the formula of 1/4 S squared √3, and we know that there are 6 of them, 6 triangles in our hexagon. I'm going to multiply by 6. And so then I would get 6 S squared √3 over 4, which would then just simplify to give me 3S S squared √3 divided by 2. Okay, so this is going to be a shortcut formula if you happen to know your side length for your hexagon to find its area. All right, now let's move into our back side of these notes where we are going to incorporate our trigonometry. So starting off, for number 5, we are asked to find the apothem, the perimeter, and the area of this regular pentagon. Well, I can easily start by finding my perimeter by taking that side length of 10 and multiplying by 5 since it's a pentagon and has 5 sides. So I have a perimeter of 50 meters. Pretty simple. The hard part is going to be when we try and find our apothem. Okay, so I'm going to draw our right triangle that we are going to deal with. And this is the apothem that we are looking to find. Keep in mind here, this length would be that 10 divided by 2 to get 5 meters. It's half my side. And then we need to know an angle, okay? So if you recall in the previous problem, which I didn't really write it fully out, but we took that 360 and we divided by our n, okay, which here would be 5, but we'll get to that in a second. And then we also had to multiply that by 1/2 or divide by 2 because we then turned around and bisected it when we drew that apothem. So we actually are using the formula 360 divided by 2n, which here, if I plug into that, is just going to be 360 divided by, and then 2 times 5 gives me 10 to get 36 degrees for this angle. Now that I know that angle, I know here that I'm using trigonometry because it's not a 30, 60, 90 or a 45, 45, 90. So I'm going to label my opposite, my hypotenuse, which should be my radius, and then my adjacent, which is going to be my apothem I'm looking for. Looking at everything that we have, in order to find the length of my apothem, I'm going to use tangent because I know my opposite and I'm looking for my adjacent. So tangent of that 36 degrees is going to be equal to my opposite, so 5 divided by my adjacent, which is my apothem, that A I'm looking for. So if you recall, when your variable is in your denominator, a real quick, easy way of solving for it is just to switch your trig function with that x, or in this case, I'm going to just use the letter A for my apothem. And so I'm going to end up that with my apothem is equal to 5 divided by that tangent of 36 degrees. And we're going to have our units, which is meters. And now you have everything you need to plug in to find its area. So we'll have that 1/2 my perimeter, so 50, times my apothem, that 5 divided by tangent of 36 degrees. Okay, so 1/2 of 50 is going to give me 25. And then keep in mind, when you have that whole number being multiplied to a fraction, you are only multiplying to the numerator. So 25 times that 5 is just going to give me 125. And then we'll have that divided by tangent of 36 degrees still, with our units meters squared. And then at this point, if you're not enrolled in my class where they're not allowed to use a calculator, you could plug this in to your calculator to get what it's actually going to be equal to. All right, moving into our last and final problem, we have number 6. So once again, we are finding the apothem, the perimeter, and the area of the regular octagon this time. So I'm going to start off by drawing my apothem here. Keep in mind, this is my radius. We're looking for my apothem, and we will also eventually need my side length so that we could find the perimeter. I'm going to go ahead and I'm going to start off with the easy one first. Let's find our apothem. Okay, in order to do that, we do need to know an angle measure to figure out what we're going to use. So I'm going to find this angle here by taking that 360 divided by 2 times my number of sides, so 8. And this will reduce down to 45 over 2 degrees, or you can change that into 22.5 degrees. Let's go ahead and leave it as a fraction so you can see that it's not that scary. So I'm going to then label my opposite, my hypotenuse, which should be that radius, and then my adjacent, which is the apothem I'm looking for. So like I said, I'm starting off with my apothem. So therefore, I'm going to use the adjacent and hypotenuse, which will be cosine of that 45 over 2 degrees is equal to my adjacent, so A. I don't know why my pen's not working. Divided by my hypotenuse, 5. All right, since here we have our number in the denominator, all we need to do is multiply it to the other side. And so I'm going to get that my apothem is going to have 5 cosine of 45 over 2 degrees inches. All right. Now that we have our apothem, let's move into finding I'm going to do side, even though it's not asked for. I'm going to break it down because in order to get to my perimeter, I need to know the side length. So with that being said, here we'll notice that the opposite that I labeled, you can't see right here, is going to be half of my side length. So if I find that, I would just double it to get my side length. So that's what we're going to do. I'm solving for opposite. I know my hypotenuse. Therefore, I'm going to be using sine of that 45 over 2 degrees is equal to my opposite over my 5, my hypotenuse. Okay, like up above, since we have that number in my denominator, I'm going to move it to the other side by multiplying it to get 5 sine of 45 over 2 degrees is equal to that opposite. Now keep in mind, once again, this is my opposite. In order to find the full side length, I'm going to need to multiply this by 2. Okay, and just to clarify, once again, remember when you're doing this, it's just going to be those outside numbers that you are multiplying together. You should still have that sine of 45 over 2 degrees. That won't change. So 2 times 5 is going to give me 10, and we'll have that sine of 45 over 2 degrees. So that's going to be my side length. Now, to clarify, this was not what I was asked for, but it's going to help lead me into finding that perimeter that I did need to know. So to find perimeter, I'm going to take my side length of that 10 sine of 45 over 2 degrees, and I'm going to multiply that by the number of sides, which is 8. So I'll get 80 sine of 45 over 2 degrees. I'm running out of room, so I'm going to put my inches down below my units. All right, and now to finish it up, we are going to find the area by multiplying everything together. Okay, so I've got my 1/2 of that perimeter, so that 80 sine of 45 over 2 degrees times my apothem, which is that 5 cosine of 45 over 2 degrees. Okay, and like what we've been doing, we're just worrying about those outside numbers, not the sine, the cosine, and what's inside of them. to simplify. So 1/2 of 80 is going to give me 40. And then that 40 times my 5 is going to give me 200. And now we can worry about putting that sine of 45 over 2 degrees back, along with that cosine of 45 over 2 degrees. And then just including my units, we'll have our inches squared. And there you have it, our final answer for the area of this octagon with a radius of 5 inches. So I will say, while this is somewhat of a long process and this can be a little confusing for some people, this topic is very repetitive, kind of like when we were first learning our sine, cosine, and tangent. So if you are applying yourself in your practice of doing your homework, then you should start building up these habits that you will see repeat every single time. The only thing that will kind of change would be your angle measure, for sure, because you're not always going to get an octagon. And then maybe even just the information that I am providing you with, such as the actual length for the radius or the apothem or the side length. Okay. But hopefully this video helped kind of clear up. And once again, for those of you that are not enrolled in my class, we are requiring them to leave it in calculator ready form. And so that's why we have the sine, the cosine left over. For you, you would just plug it into your calculator and then round to wherever they ask for.